Hey there, welcome back to another exciting session on deep learning. Today we are going to create our first neural network to classify handwritten digits using MNIST dataset. We'll be using Python and the powerful TensorFlow library with its Keras API. Don't worry if that sounds complicated. I will guide you through every step. So buckle up and let's dive in. First thing first, what is MNIST dataset? Imagine you have thousands of pictures of handwritten digits from 0 to 9. That's MNIST dataset, a classic dataset in the world of deep learning. It's perfect for learning how to build and train neural networks. We start by importing the necessary libraries. TensorFlow is a deep learning powerhouse, and Keras, which comes bundled with TensorFlow, makes building neural networks super simple. Next, we load MNIST dataset, which is split into training and test sets. Xtrain and Xtest hold the image data, while whileTrain and whiletest have the corresponding digit labels. Before feeding the data into our neural network, we need to pre-process it. We scale the pixel values to be between 0 and 1 for faster convergence during training. Then we use two categorical to one hot encode the labels. This means if the digit is 3, it becomes like this, making it easier for the network to learn. Now let's build a neural network model. We use sequential class, which lets us stack layers one after the other. First, we flatten the 28 by 28 images into single vector of 784 pixel using the flatten layer. Then we add a dense layer with 128 neurons and the ReLU activation function, which helps the network learn complex patterns. Finally, the output layer has 10 neurons, one for each digit, with softmax activation function to output probabilities for each digit class. Once our model is built, we compile it. Here we use Adam Optimizer, which is like a smart driver for finding the optimal weights in our network. The loss function categorical cross entropy is perfect for multi-class classification problems, and we also track the model's accuracy during training. Time to train our model. The fit method takes the training data and the number of epochs or training iterations and validation data to monitor the model's performance on unseen data. Watch how the accuracy improves with each epoch. With first epoch, it was 96.02, then 96.98, went to 97.33, then 97.60, and at last epoch, it went to 97.82. After training, we evaluate the model on the test data and see how well it generalizes to new unseen images. The output is the test accuracy, how often the model correctly predicts the digit. And there you have it, a working neural network for digit classification. And that's the wrap for this session. I hope you found it engaging and informative. Neural networks are incredibly powerful, and with the right understanding, they can also solve some really challenging problems. Keep experimenting. Until next time, keep coding and keep learning.